So today we are gonna do a question which is actually the differences between scalars and vectors. So we are actually doing this right now instead of the beginning lectures because we talked about vectors to a point where we can compare both scalars and vectors. That's why we are doing it right now instead of doing it in the beginning. So let's talk about the points that we must know. So, the first point, let's talk about from scalars. We know that scalars have magnitude only. So, they have magnitude only for most cases. And for vectors, they have they have both magnitude and direction. So, they have both magnitude and direction. Okay, another one. So, this is the first point. Let's change the color so that it's not that confusing to read this. So scalars, they are they are represented represented by a letter by a letter by a letter or letters and symbols or symbol or and symbol only. So if you think of an example, let's say pressure is only represented by P, time is only represented by T, and so on. So this is what we are talking about when we say they are represented by letters or symbols only. And for um, vectors, we know that they are denoted denoted by a letter or symbol um, with an arrow with an arrow over it. So let's just take some examples. If I represent d by distance, then d with an arrow over it would be displacement. But it does not mean that everything can be represented like this. For example, angle is just represented by theta, which will be the symbol. But let's say some other thing, let's say acceleration, it will be a with an arrow over it. Or you can take angular velocity, so it will be omega with an arrow over it. So there are multiple vectors that you can take, and there are multiple scalars, and we talked about what the symbol or how they are represented or denoted. So this is the second point. Now let's talk about the third point. So let's me keep this line. I'm not exactly sure if it's in the middle, but just let's make it work. So now I think we're in the third one point. So the third point, obviously this side is for scalars and this side is for vectors. So the third point is they are one dimensional. One dimensional. Okay, so they are one dimensional. And vectors are multi-dimensional. They are multi-dimensional. So why are these one dimensional? Because you can just represent them by a number, and the number line is a single line, so it's one dimensional, so 1D. Whereas vectors can be in multiple dimensions, so it can be 1D, 2D, or 3D depending on the vector. So that's why we say that vectors are multidimensional, whereas scalars are only one dimensional. Okay, another one, the fourth one is they follow, scalars follow ordinary algebra rules, which just states, so like if you add 20 plus 10, it will always be 30. But if you talk about vectors, they follow vector algebra rules. So they follow vector algebra rules. So we will actually talk about a few of them in the upcoming videos, including vector addition, subtraction, dot product, and cross product. So we will talk about this in the later videos. And finally, let's take a look at some examples. So let's talk about scalars. The examples of scalars, the most common one, are speed, temperature, etc. So I think let's add another one, mass, etc. So there are a lot of scalars, and there are also a lot of vectors. For example, angular velocity, angular velocity, torque, impulse, etc., or force, and there's so much more. So this was it for today's video. In the next video, we are going to actually talk about triangle law of vector addition. Till then, bye bye.